Good afternoon, my dear students. In the last class, we discussed differential YouTube manometer. Same will continue in this class also. And that means we'll solve more number of numericals for better understanding of YouTube manometer as well as inverted YouTube manometer. Coming to the YouTube manometer, so differential YouTube manometer in the last class only we discussed, which is used to measure the difference of pressures between two pipelines. Example, this is one pipeline, this is another pipeline. If I am interested to measure difference of pressures, then I use this. So already we know, for the benefit of our revision, then I'll write the equation. Pressure in the left limb we wrote as PA plus rho G into H. Similarly, pressure in the right limb we wrote as PB, there is pressure in the limb, plus rho GH2 because up to here, plus rho GH1. If we equate the left limb and right limb, you know the properties of fluid and the height of manometric fluid, then we will get difference of pressures. So simply what we have to do is pressure in the right limb is equals to, pressure in the left limb is equals to pressure in the right limb. So if we equate this, then you will get a equation PA plus rho GH, which is equals to PB plus rho GH2 plus rho GH1. So I know all fluid properties, then I'll get difference of pressures that we did in the last class. So depending on that, we'll solve problems. In the first problem, what we have is a U2 manometer measures the fluid pressure differences between two fluids A and B. There's a fluid A and there's a fluid B. The U2 contains mercury. See, the hatched portion is mercury. The U-tube contains mercury. Okay, that is a manometric fluid. With the help of that only we are measuring it. Calculate the difference in pressures if H1 is equals to 1.5. This distance is 1.5 meters and this distance is 0.5 meters. This distance is 0.75 meters because this is not equal. If you observe, your A portion is somewhat higher than B portion. So now, how will solve this problem? Simple. Pressure in the left limb we have to write. Similarly, pressure in the right limb we have to write, and we have to equate both equations. That is the procedure we have to follow. So if we write pressure in the left limb, what will is the pressure in the left limb? If you observe, PA pressure is there in the limb itself. So I'm taking it as PA. Okay, and plus another pressure is there on the left side, that is rho G H. Similarly, right pressure in the right limb, pressure in the right limb is equals to, what is the pressure in the right limb? See here, the PB pressure is acting here, so that is PB plus rho GH2. Can I write rho GH2? No. Why? Because the total distance is having two different fluids. If I'm writing it as rho GH2, then it is obviously a mistake because the fluid is up to here only. Some different fluid is here, and from here to here, this is manometric fluid, whose density and this density is different. The density of these two fluids is different. So what we have to do is, so what we'll do, whatever the fluid height, that means up to here, you have to write a variable. That means what is this height? Total height is H2, then it is H1, so it is H2 minus H1. So this height is H2 minus H1. So I can write it as rho G into H2 minus H1. Okay. Now what are the fluid remaining? That is manometric fluid. Coming to the manometric fluid, What is the manometric fluid? We have mercury. So what height it has? H1 height it has. So that is rho g into H1. So it is also plus. So now equate both the equations. That is pressure in the right limb, pressure in the left limb is equals to pressure in the right limb. So first I am writing PA plus, what is rho g? Mention it is water, whose weight density is given to you. Rho g is nothing but weight density. So which is equals to 9.81 into 10 to the power of 3 into what is the height? H how much is given? 1.5 is given. It is in meters, no need to convert. Which is equals to, what is in pressure right limb? PB, which is unknown, plus rho g, it is water, again 9.81 into 1000, it is 10 to the power of 3 into, what is the value of H2 minus H1? H2 is 0.75 minus H1 is 0.5, and one more variable is there, that is plus rho g into H1. It is for manometric fluid. Manometric fluid specific gravity is 13.6, comes out to be 13,600 into 9.81 into, what is height of the manometric fluid? It is 0.5. Okay. Now if you solve this equation, we have two variables unknown, A plus, what is the value this comes out to be? Use calculator all of you and tell me the value. If you solve this equation, it is coming a value of, and send this PB this side, then it comes out to be PA minus PB is equals to, send this total term that side, then it is coming a value of 54455 Newton per meter square. Okay. Now with this we will move on next question, that is same one more question on U2 manometer.